Have you ever looked up at the sun and wondered, what's its expiration date? We rely on it for everything, from our morning coffee to life itself. But what if I told you our star has a ticking clock, and its final moments will be the most spectacular and terrifying event our solar system has ever witnessed? Today, we're taking a journey not through space, but through time. Fast forward with me 5 billion years into the future to witness the dramatic death of our sun. Before we dive into the cosmic fireworks, let's understand what our sun is right now. It's a middle-aged star, a giant, stable ball of hot gas, about 4.6 billion years old. Deep in its core, it's constantly fusing hydrogen atoms into helium. This process, called nuclear fusion, releases an incredible amount of energy. It's this energy that pushes outward, perfectly balancing the immense inward pull of the sun's own gravity. This delicate balance is what has kept our star stable for billions of years, providing the perfect conditions for life to flourish on Earth. It's in a phase astronomers call the main sequence, and it's about halfway through its supply of hydrogen fuel. But like any fuel tank, it will eventually run dry. And when that happens, the real story begins. As the sun's core runs out of hydrogen, the fusion process will slow down. The outward push of energy will weaken, and gravity will start to win. The core will begin to contract and heat up immensely. This extra heat will then cause a shell of hydrogen surrounding the core to ignite, fusing at a much faster and more furious rate than ever before. This sudden burst of energy will cause the sun's outer layers to expand dramatically. Our star will begin to swell, transforming into what's known as a red giant. Picture this. Over the course of millions of years, the sun will grow larger and larger in our sky. It will become 100, maybe even 200 times its current size. Its surface temperature will actually cool down, which is why it will appear reddish. But don't let that fool you. Its overall luminosity will increase by thousands of times. The sky will be dominated by a colossal, glowing red orb. For any life that might still exist on Earth, this is the beginning of the end. The oceans will boil away, the atmosphere will be stripped, and our planet's surface will be scorched into a barren, molten rock. As a red giant, the sun's expanding outer layers will consume everything in their path. Mercury and Venus, the innermost planets, will be the first to go, vaporized by the star's fiery embrace. What about Earth? Our planet's fate hangs in the balance. Some models suggest Earth might just barely escape being swallowed whole, but it will be a hollow victory. Even if not physically engulfed, Earth will be so close to the sun's surface that its rocks will melt, leaving a lifeless, charred cinder. It will be a world completely unrecognizable. Mars, once a prime candidate for colonization, will also face extreme heating, its thin atmosphere and any remaining ice blasted away. Meanwhile, back in the sun's core, a new chapter is starting. The immense pressure and heat from the contracting core will finally reach a point where helium, the byproduct of the earlier fusion, can begin to fuse into heavier elements, like carbon and oxygen. This process ignites in a cataclysmic event known as the helium flash. It's an explosive, runaway reaction that releases an enormous amount of energy in just a few minutes. But it's all happening deep within the sun's core, so we wouldn't see it directly from the outside. This new energy source will temporarily stabilize the sun. It will shrink slightly from its peak red giant size and burn a bit hotter for a while. But this phase is short. The helium fuel will be used up much faster than the hydrogen was. Once the helium in the core is exhausted, the sun's fate is sealed. The core will again start to collapse under gravity, and the outer layers will expand once more, making the sun an even larger, more luminous red giant. During this final phase, the sun's hold on its outer layers will become very weak. Strong stellar winds will begin to blow these layers away into space, creating beautiful, expanding clouds of gas and dust. This is the stage where the sun creates its final masterpiece, a planetary nebula. Don't let the name fool you. A planetary nebula has nothing to do with planets. They were named by early astronomers who thought they looked like gas giant planets through their small telescopes. In reality, it's the glowing, ejected layers of a dying star. For thousands of years, the sun's outer shell will expand outwards, forming intricate and colorful patterns. It will be a stunning cosmic light show, a final, beautiful farewell from the star that nurtured us for billions of years. Imagine seeing this from a distant star system, a vibrant, shimmering bubble of gas illuminating the darkness of space. It's the ghost of our sun. So what's left behind, after puffing away its outer layers? All that will remain of our magnificent star is its superdense, scorching hot core. This remnant is called a white dwarf. It will be an object about the size of Earth, but containing roughly half of the sun's original mass. A single teaspoon of its material would weigh several tons. This white dwarf will no longer be producing energy through fusion. It will simply be a cooling ember, glowing with leftover heat. It will be incredibly hot at first, shining with a brilliant, blue-white light. This intense ultraviolet radiation is what will cause the surrounding planetary nebula to glow so beautifully. But this final glow won't last forever. Over an unimaginably long time, trillions of years, far longer than the current age of the universe, the white dwarf will slowly radiate away its remaining heat. It will fade from white to yellow to red, and finally it will become a cold, dark, inert ball of carbon and oxygen. Astronomers call this theoretical final state a black dwarf, a cosmic cinder drifting silently through the galaxy, a dark tombstone where a vibrant solar system once thrived. The planets that survived, like Jupiter, Saturn, and the other gas giants, will continue to orbit this dark remnant, frozen solid in the eternal night. This might sound like a sad and lonely end, but it's a vital part of the cosmic circle of life. The elements that our sun created and then cast out into space, the carbon, the oxygen, all the material in that beautiful planetary nebula, will become the building blocks for the next generation. This cosmic dust and gas will mix with other interstellar clouds, eventually collapsing under gravity to form new stars and new planets. The atoms that once made up our sun, and even our own bodies, will be recycled. In some distant corner of the Milky Way, billions of years from now, a new star will ignite, and perhaps around one of its new planets, a new form of life will look up at their sky and wonder about their place in the universe, completely unaware that they are made of stardust from our long-dead sun. So, while the death of our sun means the definitive end of our solar system as we know it, it's not truly an end. It's a transformation. It's a spectacular, powerful, and beautiful part of the universe's ongoing story of creation and renewal. The cosmos is in a constant state of change, and our star's life and death are just one chapter in that incredible epic. It's a humbling reminder of our tiny, precious moment in the vast expanse of cosmic time. Thank you so much for joining me on this journey into the distant future. It's a mind-bending thought, but one that deepens our appreciation for the here and now. If you enjoyed this cosmic perspective, please hit that like button and subscribe for more adventures through space and time. Let me know in the comments what other cosmic mysteries you'd like to explore. Until next time, keep looking up.